going to discuss enzyme inhibition. The term inhibition means basically stopping enzyme action. And if you have an enzyme and you have a substrate and the substrate binds to the active site, the enzyme will do its thing, it will catalyze the reaction, and you're going to have product. Well, how can you prevent the substrate from binding to the active site? And that's what inhibition is all about. There are two types of inhibition. There's competitive inhibition and non-competitive inhibition. Competitive inhibition means that you have an inhibitor molecule that prevents the substrate from binding to the active site. And that inhibitor molecule looks exactly like the substrate. So it competes with the substrate for the active site. So they look very similar. And if the inhibitor gets to the active site before the substrate and binds, then the substrate can't bind. The inhibitor is stuck there, and the enzymatic reaction stops. Okay, it competitively inhibits the reaction. Now, a competitive inhibitor, if it comes and binds there covalently, it becomes pretty irreversible. It's really hard to change that and allow it to occur again. Now, with a competitive inhibitor, remember that the inhibitor molecule looks like the substrate. That's the thing. Now, to overcome competitive inhibition, sometimes you just have to bombard the system with tons and tons of substrate. And so then the substrate is more than the inhibitor and it competes and it'll bind there more often. And then you can diminish the effect of the competitive inhibitor. Now, for a non-competitive inhibitor, the inhibitor doesn't look like the substrate. The inhibitor does not look like the substrate. So structurally, the non-competitive inhibitor doesn't look like the substrate. Well, how in the world can it prevent the substrate from binding to the active site? Because if it doesn't look like the substrate, it's not going to bind in the active site. And true, a non-competitive inhibitor does not bind to the active site because it doesn't look like the substrate, so it can't bind to the active site. It actually binds to an alternate site. And sometimes they call this an alternate site or allosteric site. Get that terminology in your notes. So then how can a non-competitive inhibitor that binds to a different site on an enzyme inhibit the substrate from binding to the active site? Well, remember that induced fit model? So when a non-competitive inhibitor binds to an alternate site on the enzyme changes its shape a little bit and maybe closes off the active site, or something is altered, and therefore it prevents the substrate from binding into the active site. So non-competitive inhibitor, remember, the inhibitor molecule doesn't look like the substrate, it binds to an alternate site. When that happens, then the enzyme shape changes, and then the substrate can't fit into the active site, and the enzyme has been inhibited. A lot of the non-competitive inhibition can be reversed, because if the non-competitive inhibitor just leaves that alternate site, then the enzyme will take its original shape again, and then the substrate will be able to bind to the active site. There's a type of inhibition that is non-competitive that is called feedback inhibition. But in order to understand that, we have to talk a little bit about the term pathway. What is an enzymatic pathway? Enzymatic pathway. And many things in metabolism are enzymatic pathway, where the product of one reaction becomes the substrate of the next reaction. In fact, you're going to see in glycolysis in chapter 24, you have glycolysis is an enzymatic pathway. It's got 10 enzymes. The product of enzyme 1 becomes the substrate of enzyme 2. the product of enzyme 2 becomes the substrate of enzyme 3. So we're going to show this way. So we're going to say S1, S2, S3, S4. So this would be enzyme 1, enzyme 2, enzyme 3. Pretend that this is a pathway. Let's just keep going. Maybe this one over here is the final product. So this is final product. And this would be enzyme 4. All right, so this is a pathway, a hypothetical pathway that has 4 enzymes. So this is the initial substrate, and it becomes an enzyme substrate complex, produces a product. But remember how I said in a pathway, the product of one enzyme becomes the substrate of the next enzyme. And then this becomes an enzyme substrate complex and then produces a product, but then this product becomes the substrate of this enzyme. And then this product becomes the substrate of this enzyme. So that's why I'm calling these guys substrates instead of calling them products. So let's say that the end of the pathway is this final product. In the term feedback inhibition, this occurs in enzymatic pathway. And with this, usually the final product comes back and inhibits the first enzyme of the pathway. Now think about this. Would this be competitive or non-competitive? If you have a pathway and you've gone through all these steps and now you have a final product, it's very, very unlikely that this is going to look exactly like this substrate. And so if this doesn't look like this substrate, no way on earth is it going to compete for the active site. So if it doesn't look like it, it's going to be non-competitive inhibition. So this is going to come and it's going to bind to an alternate site on the enzyme. It'll force the enzyme to change its shape, and then this substrate won't be able to bind, and the whole pathway has been blocked. Okay, and so now we have to have an alternate route for this. This is going to go in a different pathway or be turned into something else or just start to accumulate in the cell. All right. So with feedback inhibition, it is a type of non-competitive inhibition where the final product of a pathway feeds back and usually comes and non-competitively competes, non-competitive with the first substrate for that first enzyme of the pathway, and it binds to an alternate site. Okay, good. We are all set with the basics of enzymes, and we're ready to move on.